Welcome back. We were discussing in lecture 14 about normal stresses on vertical plane, and normal stresses on vertical planes can be determined by considering the equilibrium of horizontal shear forces above or below a hypothetical element within the body of a dam. If you will consider a hypothetical element or a wedge in the body of a dam, you can take the shear forces above and below over the elements and the differences in the shear forces above and below the hypothetical element are balanced by normal stresses on the vertical planes. So here is your wedge over which this force and this force, you can say, stresses are working, and this is tau yz and tau zy are the complementary stresses. So we have to find out the normal stresses, and normal stresses are nothing but these expressions, you can say, are the normal stresses. I have earlier shared the PDF in which these formulas are written to you. You can easily solve it out on your copy on or your rough notebook, so that you can be easily familiarized with these expressions. Here is the view one of about this section of this wedge, which can be clearly seen in this figure. Here you can see this angle of internal friction phi 0 phi u, sorry. These are the forces and these are the stresses acting on it. And in view 2, you can see this view 2, and these are the forces. Now let's talk about principal stresses. What are the principal stresses? Principal stresses are the maximum and minimum stresses. Yes, principal stresses, both maximum and minimum stresses that may be developed at any point within the body of a dam. So, usually we are denoting maximum principal stresses with sigma 1 and minimum principal stresses with sigma 3, and they are oriented or inclined at a certain angle of reference from horizontal or vertical lines. Now, the point is that how can we calculate the values of maximum and minimum principal stresses? So, here is the answer. We can calculate the values of maximum and minimum principal stresses, or we can say sigma 1 and sigma 3 values we can calculate by the sigma z, sigma y, and tau yz, which are the state of stresses, which are the normal stresses sigma z and sigma y, and tau yz, the shear stress. So, what is the formula you may obtain for maximum principal stress? Then, so the formula for maximum principal stress is the sigma z plus sigma y by 2 plus square root of sigma z minus sigma y by 2 whole square plus tau zy square. If you can put, if you will put the summation sign or plus sign here you will get the maximum principal stress. If you will put here negative sign or subtraction sign, then you can get minimum principal stresses. So after putting here plus sign, then you will get maximum principal stress, and the value is sigma 1, and sigma 3 will be obtained by putting the negative sign here. Now, so here we are here we were discussing about maximum and minimum principal stresses. Now, how can we get maximum shear stress and minimum shear stress? So we have to calculate the values of maximum shear stress and minimum shear stress, and the values are obtained by the formula. Here you can see in the formula of maximum principal stresses and minimum principal stresses, if we can eliminate the first part before the sign sigma z plus sigma y by 2 along with the sign plus minus, if we can remove this part from this expression or this equation number 24, we will get maximum and minimum shear stresses. And here is the formula: tau max is equal to sigma z minus sigma y by square by 2 square plus tau yz square. So now as you were taught these expression earlier in your strength of material subject in second year, so we are deriving the basics and logics, and we have to ensure that what fundamentals and what basics are applicable on our study, on our focus, and the our study point or study focus is prima facie is concrete gravity dam. So on the concrete gravity dam, upstream and downstream faces are the planes of zero shear. So you can say if we will put this value 0, then this value will be hypothetical. Or if suppose this value will become 0, then sigma 1 is equal to sigma z plus sigma y by 2, or sigma 3 is equal to sigma z plus sigma y by 2. So the principal stresses at these faces are given as sigma 1 u is equal to sigma z u sec square phi u minus pu tan square phi u, and sigma 3 u is equal to pu. Similarly, we can here we are using u subscript for upstream phases, and here we are using d subscript for downstream phases, and the rest formula is same. So these are the maximum principal stress, minimum principal stress, maximum shear stress, and minimum shear stress, and their applications on the concrete gravity dam we have studied so far. So we have to remember two main formulas from the strength of material subject, and we have to ensure the application of those formulas, those concepts on the upstream and downstream phases of the concrete gravity dam by assuming a element within the body of the dam, and we have to consider the frictional forces above and below the surfaces of the element assumed, and we get the difference between above and below the surfaces of those assumed element, which will help in the further calculation of stresses. So I would like to suggest you that this topic is very much of importance for the exam point of view of Rajasthan Technical University.